Okay, so let's take a look at some examples here of questions. So the first question I have here, it says the sum of two real numbers, x and y, is 9. So the sum of two real numbers, is 9. And they say express y in terms of x. Okay, so y in terms of x, so y has to be the subject. So 9 minus x. Okay, that was pretty straightforward. Then they say, given that p equals x squared y, so there's something here about p equals x squared y, write down an expression for p, okay, an expression for p in terms of x. Okay, so basically what they want here is I actually need one input value to get the value of p. In this case, I have two inputs. I have x and y, so I have to need, this is basically just simultaneous well, let's say equations. So I'm just going to put this y in there. So let's do p is x squared, and then the place of y, I'm doing 9 minus x. So that's nice and factored like that. But if I wanted to, let's say, expand the brackets, then I'd have 9x squared minus x to the power of 3, or x cubed. Okay. Now they say find the maximum value of p. So in order to find the maximum value of p, this is a function, I need to actually just derive this function. And for a maximum point, it'll actually be a stationary point, right? So let's just derive this, but I'm deriving, it won't be dy over dx, but because it's dp, because p is changing over the change in x. And then, yeah, just normal deriving. So I'm going to have 18x minus 3x squared. And this will obviously need to be equal to 0 if I wanted to find, they're saying, a maximum value of p. So that would be a stationary point. So I'll have to say this is equal to 0. I can factorize this out. I can take out a 3x actually. And then what's left on the inside will be 6 minus x. Yeah, that's fine. And that would be 0. So I have two answers here. X can be 0 or x can be 6. And I don't think 0 is going to work here as a maximum point, but yeah, basically just find the maximum value of p. So that would be, yeah, 0 is just going to give me 0 everywhere. So if I input 0 in there, that's definitely not going to give me a maximum. So basically this is going to be the minimum point. So this I'm assuming if I were to draw this, but the maximum value, yeah, there we go. And next they say, oh, yeah. We have to find the maximum value actually. So we have to input the x into our function. So let's do that in a different color. We have p is equal to x squared. So I'm going to put in 6 squared, obviously in brackets. Doesn't really make a difference in this one. But 9 minus 6, and that is going to be 36 times 3, right? And that would give me 108. So the maximum value of p is 108. You can see if I put in 0, I'll just get 0. So that won't really work as an answer for me. So this one I'm pretty much happy with. And next they say, oh, that's a new different question, or a C part of the question. They're saying, given that Q is equal to, so I'm just going to write this here, Q is equal to 3x squared plus 2y squared. Write down an expression for Q in terms of x, and then find the minimum value of Q. Okay, so I'm just going to have to do this again, x squared, and put this y in here. So 9 minus x squared, and do some expanding of brackets. So 3x squared, the plus 2 I'm just going to keep outside. So 9 times 9 is 81. And 9 times negative x times 2 is going to be negative 18x. And then that times that is just going to be plus x squared. That's all fine. And then I'm gonna add in, well, just carry on with this. So 2 times 81 is going to be 162. This is going to be minus 36x, and then plus 2x squared. And I have like terms here, so those would add up to 5x squared minus 36x plus 60, well, sorry, not 60, 162. Okay, so this is now my expression, but I need to find a minimum point, so I'm going to have to derive. So let's just derive. It's going to be dq over dx. I'm going to have 10x minus 36. Just that. That's pretty straightforward. And well, to find a stationary point, I'm going to have to equal it to 0, and then 10x will be 36 and x will be 3.6. Okay, that's pretty straightforward. And now I have an x value for the stationary point. I could only find one stationary point, so I'm just going to assume this is a minimum point because there was nothing else. Don't really think I have to assume this. This is a positive parabola, so it'll look like that. So the only stationary point will be actually a minimum point. Okay, and then we have to actually find the value, the value of q at that point. So for that, I'll have to put in this x36 into this function over here. Just sub that in, and I have done it before in my calculator, and the answer was 97.2.